Live. What is up, everybody, and welcome to live stream number 112 of the Data on Kubernetes community. The 111 live streams that we've done before this got us prepared for today. Super stoked. This one has actually been months in the making. When I got to know Jonathan for the first time several months ago, we've had some different things going on. Finally got back together, making this happen. Before we got started, as usual, folks, check us out on Twitter, check us out on LinkedIn, subscribe to our YouTube channel, jump in on Slack, get in on the action. We have plenty of things going on. We've got live streams all the way through the end of this month. Tons of stuff going on in February. Got live streams planned all the way through March and now into April. Has some new things coming up as well. You can expect to hear about localized meetups, starting out virtual, respecting COVID limitations, but hopefully in the future moving to local in-person meetups. So you can expect more news about that. And speaking of news, we've got our third co-located event in KubeCon, right? Our third KubeCon that's going to be coming up on May 16th, right? But I'll leave the CFP for you here. If you want to give a talk, just remember, we're not looking for vendor pitches. We are really not looking for vendor pitches, and we are certainly not looking for pitches from vendors. That being said, the instructions are very clear on the Sessionize link. You can see all the stuff that you need to know about what kind of talks we're looking for in terms of format, content. You can also propose panels, some very clear guidelines about that. Now, we've had a couple of talks about, out of the 111 previous live streams we've had a couple of talks that have focused on the nature of Postgres. The super loved, well-known, battle-tested database, got tons of fans all over the world, and Jonathan happens to be one of them. Jonathan, welcome to the Data on Kubernetes community. Great to have you here with us. Could you just give us a little bit about your experience, how you got started with Postgres, and how you got started with Kubernetes?
Wow, that's a loaded question. So first, as a recovering event organizer, I must say that seeing you have everything booked out months in advance, including talks, is incredible. And definitely a major kudos to that. Like that's something I certainly admire. And I'm not just saying that just because you let me speak here. But so I got started in Postgres is actually we could probably spend an hour on that. But it started as an application developer. This was back when I was hacking in high school, trying to build websites, which was, I don't like to admit how long high school was ago, despite youthful appearance. But I started from that. And I started just building websites on it, and I fell in love with the features. Instead of just trying to do things through an ORM, I was like, let me dive into my database layer, write raw SQL queries. So use Postgres full support for data types and indexes. And what so happened is that Postgres ended up becoming very popular for a lot of different reasons, and you were able to make a full-time living off of either just managing Postgres databases or being part of a vendor company. And that's ultimately what got me into Kubernetes. Is I joined Crunchy Data, and Crunchy Data had already been running Postgres on Kubernetes for several years. And this was over 4 years ago when I joined. And I was like, this is cool. Let me, dive more into this, containers world. This seems like they're going to be kind of important, and everyone's going to be using them in a few years. And fast forward to now, we're having this conversation. And I think, and I don't know if this is going to segue too much into today, but what I've been looking at was not so much about, running a database in containers. It was, how do I run Postgres in a production environment on Kubernetes? And this just comes from having been the accidental system administrator DBA. I'm an application developer at heart, but I always would find myself having to, manage the database at the end of the day. So how can we make it easy to do that, in a production environment?
Very, very good. Well, that's a nice way to get started out. That being said, folks, as usual, we want this to be as interactive as possible. If you've got questions, leave them in the YouTube chat. That being said, Jonathan, if you want to share your screen, jump into your presentation, go for it.
I do. I actually did not mute notifications. Oh, hang on. Let me just mute notifications.
That's okay. Always important. There we go. Because they will jump out.
Yes. They will. All right. So we are going to share my entire window. And I'm going to bring up my slides. And I will forewarn you, this is not a product pitch. This is not a vendor pitch. Some things might read like that, but actually what we're talking about is all open source. And we're going to talk, and really the pith of this is going to be a demo. So with that, would you like me to just take it away and dive into it, or anything else you'd like to say before we begin?
No, it's all you. Take it away.
Cool. All righty. So briefly about myself, I don't like talking about myself too much, but as Bart alluded to, I've been around Postgres for many years. I've actually been active in the Postgres community for well over a decade. Started out on the event organizing side, trying to encourage people to use Postgres by planning local user groups, conferences, etc. And graduated into some more of the governance type aspects of the project. Beyond that, I've been in the startup world for a very long time, and I joined Crunchy Data because I just wanted to work on Postgres full time. Brief plug about Crunchy, if that's okay. All we do is open source Postgres. We love contributing to open source projects, including the Postgres upstream. We have a certified open source Postgres distribution. We do stuff with Postgres on Kubernetes, as this talk will convey today. And we also have our own fully managed cloud service called Crunchy Bridge. So now that we have the pleasantries out of the way, let's dive into it. So as I mentioned at the top, my thesis when coming to Kubernetes is not so much like, can I get something up and running on Kubernetes? I think in many ways that's a well-solved problem, but even still, like, I think in some ways it's well-solved, some ways it isn't. Kubernetes continues to evolve very rapidly in a lot of different ways. I mean, on the Postgres side, we've been very excited about the Kube 1.2.2 release, for this, for the support for cgroup version 2, for being able to support swap, which is very important for running a Postgres database within that environment. But it also means that as Kubernetes evolves, we need to make sure we can tailor to Postgres to run within the production environment. And the reason production is so important to us is that, and really to me, personally, is that that's ultimately where my data is going to live. Like, I can do all sorts of crazy things in my development environment and test things out, but if I can't get it to run in production, then what's the point? It suddenly is just an experiment. I've seen this with particular Postgres features. I have a talk just how to run, use a feature called the foreign data wrapper, and how easy it was to get it working in a dev environment. That brought it to production. I was like, oh, there's all these like different security concerns and other things I need to work on. So this is why a lot of what the focus on from the product and engineering side has been, what can we do to not only make it possible to run Postgres in production on Kubernetes, but make it easy. You don't want to have to worry about managing a database. You want to worry about building your application. Like, that has always been my mindset as the app developer, is like, just give me the connection to the database, and then I'll do all the rest. So this is where Crunchy Postgres through Kubernetes comes from, and read this as the Postgres operator, PGO, for short, and for the rest of the time I'm going to refer to it as PGO. PGO's been open source for 7 or 8 years. I've lost track now. It's been a long time, and like really has been battle tested in production environments, and we've continued to evolve it through the years. And diving into this, and what I'll say is we're going to dive a little bit into like the general user experience, the general features, and then we're just going to demo, because that's why we're here. Like, we're going to actually look at running an application with typical production environments. So what's important when you're trying to deploy anything in Kubernetes? I mean, first you need to be declarative. Like, this is why I love Kubernetes, is that I'm just going to define what I want to deploy, like what my topology looks like, and then boom, like it should just appear. When I'm deploying a deployment, I want 3 replicas of my application. I want them to be distributed across this pod topology, and maybe I have some tolerations that I want to set for them. Like, I don't necessarily care like how Kubernetes does it. I just trust Kubernetes to do that. We want the same experience for our databases, even whether it's Postgres or not. So this was like one of the first big design decisions of PGO, was that let's make it fully declarative. Everything. Like, I want high availability. I want my backup stored somewhere. I want monitoring turned on. Let's make it so you just say, I want those features, and then the operator takes care of the rest. I can set and forget. GitOps, this is another big advantage of running things in Kubernetes, is that you're able to successfully version your manifest, be able to move forward and back in time. And with databases, it can be a little bit trickier, particularly if you're doing destructive things like a point-in-time recovery. But we can get as close to GitOps as possible, and with a lot of the other operations involved. So PGO, just the long story short, is it works with all the tools. The last 3 points are really, what we're going to focus on today. I mean, I guess the first 2 as well, since I will be making changes to the manifest, live in real time. But make it easy to get started. Let's get a production database up and running. That's a pretty powerful statement. But when I'm in production, I have concerns as well. I don't want things to go down. I want to make sure that if I need to update my Postgres version from 14.1 to 14.2. That there's minimal or no downtime. Let's learn from Kubernetes. Let's apply something like a rolling update, and let's make sure that we feel comfortable running my applications in it. So I'm gonna go over a few architectural concepts that are important. I would say, they're certainly important for Pico, but they're also important, I would say, for running, anything where you're backed by a key stateful service. And the first is this notion of being declarative. I feel in some ways this is redundant talking about it to the Kubernetes community, but I think I do like to bring this up because I think declarative is important. This is why Kubernetes is so popular, is that I build out my YAML manifest. I say, like, I want my HA, I want my DR, I want my monitoring. I put it up to my API or my custom resource, and Pico just takes care of it, or an operator takes care of it, or a controller in Kubernetes takes care of it and deploys it as you want. Now, looking at this diagram here, hopefully it's legible. It's certainly legible on my big screen, but I think for me, the important bit of this is, not just that we have this topology, but how do I connect my application to it? And we're going to see that we're going to leverage kube secrets to basically say, all your connection credentials are in there. You don't even need to look inside them at all. There, you just, plop them in, and everything just works through their application. So we're up and running. That's great. But now we get into like day 1 and day 2, where things happen, things go wrong. One of my favorite support tickets I ever received, I received, with an earlier version of Pico was, hey, we accidentally deleted our connection pooler, but it never respawned. Well, that's pretty bad, right? Because we need that to come back up. If you delete a deployment or delete a service, they don't automatically come back up. That's where an operator helps. And this is a great thing about the operator pattern in general, is that it can detect those changes and like automatically heal them. But that's only one side of the equation. An operator can certainly help maintain the state of how you want your Kubernetes objects deployed. But then there's availability within your stateful services themselves, including Postgres. You want to make sure there's no single point of failure, and we'll see how Pico handles that. Some key aspects are, high availability uses distributed consensus. Actually, we leverage the Kubernetes APIs for that. Disaster recovery, backups can run independently of the operator. Same with monitoring. So updating. There's many reasons why you might want to update. The first reason is, there's, CVEs are coming out all the time. Your base image, needs some updating. You need to update, your Postgres image or your backup image or whatever it may be. Or you might need to resize your Postgres cluster. You need to add more memory. You need to add more, CPU resources. I mean, all those are destructive operations. So you want to make sure that updating has, minimal impact on your cluster. And then being able to do continuous delivery, ensuring that, even though I'm talking about production grade, that you're able to build the cluster up in your, various environments. And, having, the declarative workflow certainly helps with that. Just one point on here is, being able to, infrastructure agnostic. I think you get this inherently with Kubernetes, but, being able to store, something like your backups in multiple locations. Something I did even before I came to the Kubernetes world was that I would keep, I'd have Postgres cluster, my main Postgres cluster in the main data center, another one in a different data center. I'd store my backups in multiple places because, data is, generally, the critical piece of your application. That if something bad happens to it and you get into an unrecoverable state, then that you certainly have challenges. So we're almost to the demo. Again, just to highlight features you should think about when you're in a production environment and how to, and how to look at it. High availability. I think there's a lot of focus on this, particularly in Kubernetes, is that you want to make sure that you're always available. But you also want to make sure to do it in a way, where you're not, necessarily sacrificing, things around, well, you want to sacrifice things around data integrity. And this is where I think disaster recovery is really important. Making sure you have backups, making sure that you're able to restore quickly from your backups, and, being able to put them flexibly anywhere. And then monitoring, because, with monitoring, you're able to anticipate problems before they occur, such as, running out of disk or, a runaway query. Other things that, an operator can certainly help with, not just Pico, is, being able to provide security out of the box, running with unprivileged containers, enabling TLS by default. In the case of Pico, Pico brings its own PKI. Having, performance, being able to like tune your cluster, fairly easily, be able to clone data, and add things like connection pooling as you continue to scale out. So without further ado, let's get into the demo. I hope this says, helps set up the context, in general, like, not only like what you look for when running a database in production, let alone Postgres, but the general framework. So just to show there's nothing up my sleeve, I'm in my Kubernetes cluster. I'm actually using a local time cluster. I actually went ahead and deployed the Postgres operator. There you go. So you can see it's up and running. And I've already created a few manifests to deploy everything. So we're actually going to go through the script I set up all together. We're first going to deploy our application and our monitoring stack, and I'm going to explain what I mean by all that in a moment. So let's get everything up and running. Cool. So today we're going to be deploying Keycloak, and have Keycloak backed by a Postgres database. Keycloak is an identity management application. It's pretty cool. We actually use that crunchy data for a bunch of different things, and we're going to have a Postgres database connected to it. So I'm going to go through the manifest real quick here, and explain some of the different things here. So first, you can see like we're loading in our Postgres image, and we're specifying high availability. Now in this case, we can run 2 replicas and have high availability because of using the DCS that Kubernetes provides. I set up 2 different backup repositories. One is using local Kubernetes storage. The other is using my S3 bucket, and we'll see. We're going to have some fun with that later. I won't spoil the surprise. I've deployed a monitoring sidecar, so that way we can start exporting metrics. So some of those will be available by the time we look at that. And some other things just to help deploy our Keycloak database. Our Keycloak application. Now, here's my favorite part of this. This is actually the favorite part of the entire demo for me, and it's binding our application to the database. All of the credentials exist, within a secret. And within the secret, so basically, I don't even need to know what the user credentials are. I can just make a reference to the secret to my application manifest, and everything is there. We can actually inspect that a little bit, but just to get a little bit ahead of the demo, I'm going to take a manual backup to S3, which is going to be helpful later. And even like with things that are imperative actions, like specifying a backup manually, we do that declaratively in the sense that you annotate the custom resource definition, Pico detects that, and then goes ahead and makes the backup. You can schedule backups on your own and have them occur using kube cron jobs, and I strongly recommend that you set that up anyway. So let's see our application up and running. First, to show that there's nothing up my sleeve. Because I'm using my local kind cluster, I'm just going to port forward it. And here we go. So here's Keycloak. This is the welcome screen. I'm going to log in. And here we go. I'm in the main screen for Keycloak. That's it. That's pretty cool. Let's see if I can save some data. All right. There we go. Data saved. Great. So like our application's up and running. We're against a highly available Postgres database. So you might not believe me yet. That's highly available, but we'll see that in a little bit. Actually, here, let me show you what the topology looks like. So we can see we have our 2 database instances here. Well, one backup job completed, one's still running, the one to S3, which is going to take a little bit of time, but we have our application up and running. So cool. Like we got everything up and running. Now, let me just ensure you that this is not a trick. We actually saved data to our database. Let me exec in. So there's multiple ways to connect to the database. There's a secret that contains the database credentials, which you saw that I bound to the application. You can, of course, take those database credentials and connect directly. You can also exec into the pod, which is, since I have exec privileges on my local cluster, I'm doing that. And we can see that, lo and behold, our data was saved to the database. One other thing I just want to show, we do use the latest version of the custom resource definition, version 1. So I do suggest, if you want to play around with our, this wonderful open source software, you can, certainly explore just through, kubectl explain. I do strongly recommend reading the documentation and going through the tutorial because you will learn lots of cool things. And it was also, for me personally, it was a lot of fun to write because it allowed me to really explore the software that we built. All right, so we have a cluster, we've done day 0. We have a cluster, it's up and running. We've connected our application to it. Everything seems good, everything seems great. But as we know in production, chaos can occur, and chaos can occur in a lot of different ways. One of the most important elements in our cluster is a service. Why is a service important? A service is a stable endpoint. Basically, it lets you know that you can always connect to whatever it may be, your application, your database, et cetera, through this endpoint. An important one for us is this one called Keycloak DB primary, which is a stable endpoint to whichever Postgres instance is your primary, or the one that accepts reads and writes. It would be a bad thing if that service gets deleted. In fact, if under normal circumstances, if I delete a service, it's gone. Oof, you don't see it ever again. So I'm going to delete that service and try to create havoc. But we'll see that when it comes back up, it actually comes back up almost instantly. It's like the service was never deleted. And that's because Pico, the operator, detected that the service was deleted and recreated it. And this is like the fundamental power of the operator pattern is, the operator is constantly watching for what's going on in the environment. And in production, if you see something that's out of whack, you see something that's either going against what your manifest currently states or what an operator expects to be there, it should go in and fix that. So let's make sure that our application is still up and running, and it appears to be so. And it appears that I can still save data to the database, at least through the UI. And again, to show there's nothing up my sleeve, I'm going to exec in. And we see that, there, lo and behold, our data is still there. Cool. All right, so we survived like one day one type scenario, which is, something happened in my Kubernetes environment, and we were able to recover from it. We were able to automatically heal. So let's scale up, or actually say let's scale out. Let's add another instance, because 2 instances in this case, 2 Postgres instances in this case give us high availability, but 3 is better. 3 gives us a little bit more resiliency against 1 node or 2 nodes or what have you going down. So what I'm going to do is I'm going to go into our manifest. I'm going to change replicas from 2 to 3. And then I am going to first make it easier for me to click through things. And I'm going to do a kubectl apply and have the changes roll out. So I'm actually going to open up a different tab so we can see the new instance coming up. So we can see that we have a primary. We have a replica, and we have this new instance initializing, which as part of the initialization process, it needs to get a copy of the data. The way Pico does this is that if it uses one of the backups to speedily recreate that information, and then it attaches it to the current primary to get up to date, and it becomes a streaming replica. So we can see that we have everything up. Great, we have 3 instances. So let's have a little bit of fun. Let's get into, I don't know if you would consider a day 1 or day 2 operation, but let's get into a software update. Let's say our application is wildly successful. We need to tune our memory a little bit. Let's give our Postgres instances, a little bit more memory, and subsequently, we could do some adjustments to the Postgres configuration itself. So what we will do is that we're going to set a memory request for our instances and say, we want to have a 1 GB memory request. Now, depending on your production application, that might actually be way too little memory for your database. Because I'm on my local machine, I don't want to totally blow up my memory. But let's apply this change. Now, what I'll notice that when we do apply this change, this is a destructive operation because basically we're going to the stateful set and saying, we need to adjust the memories, which means that we have to recreate our pods. So what Pico does is it does this in a rolling fashion. It first takes a replica. It takes it down and makes sure that it does a safe shutdown, make sure it's, it applies the change, make sure it's healthy. Then it goes to the next pod. So in this case, we're handling the second replica. And, it's the same process that we're going to make sure we can shut it down safely. We're going to bring it up. And then when we know it's ready and able to accept connections and healthy, at this point, we're going to go after the primary. So what we're going to do is a controlled switch over, which we can see here where we promote the most healthy replica. That becomes the new primary. all the connections get rerouted there. And we take down the old primary and apply the change to it. So first, let's make sure that there's nothing up my sleeve here, that we actually applied all these changes. And I'm going to take the value of the, so I'm going to take the name of the old primary. And since I usually look at the YAML, I always slip up where I'm looking for the memory request, but here it is. Our memory request succeeded. It is definitely on the new pod. So great, we actually did apply these changes. And our application should still be up. Now, sometimes with Keycloak, there might be some connection retry logic that will get it into a loop. In this case, it didn't, probably because I stated one of the holes sometimes I poke in the demo. But let's make sure that we're still able to save. We are indeed going to a new database now, but it looks like the value saved. And if we do an exec into it, voila, the data is there. So cool. So we got through some fairly common things that occur when running your database in production. I mean, one, we created the database, we connected our application to it, we made sure everything was working. We dealt with some scenario, some chaos scenarios that occur that could potentially cause downtime, but we recovered and we saw that in this case we had no downtime. And then we saw that our application needs some more resources, or call that a software update. We applied it and we did it in a way where there was no disruption to our application. Cool. Now let's take this to the next level. And let's do something that's definitely very day two oriented, which is preparing for disaster. There's certainly been a lot of advances in Kubernetes over the past few years to make it easier to run multi-cluster Kubernetes environments. And by that, I mean having multiple Kubernetes clusters and spreading your applications and your workloads across them. One of the critical linchpins of that is your Postgres data, or any database, but in this case, a Postgres database, and making sure that we're able to get the data and the information between the two and set us up for promotion or failover scenarios. So in real time, we're going to create a standby cluster in a different data center. Now, first, let's make sure we're going to be leveraging S3 as our broker here. That's not the only way you can do it. You can leverage different backup storage systems. But the reason we use the external third party is that it gives us a broker to be able to get the information between both systems. So we see that, recall that our second backup repository was the S3 repository, and we do have a backup there. So we know that there's information there to create the standby cluster. So let's go ahead and do that, because that's going to take a few minutes. All right, so that's being created. So our standby cluster is actually going to look very similar to our primary cluster. And that's by design. I want to make this as homogeneous as possible. But the one difference is that we have the session called standby. It says enable true, and it's pointing at the backup repository we're using to bootstrap and continuously read in some of the data. I'm hoping this is as easy as one can make it to create a standby Postgres cluster. For application, we are deploying Keycloak in that second data center, but in this case, I'm not starting it up right now. I do need to dive in to see if Keycloak has a read-only mode, and I will probably do that for the next time I demo this. Or it is a way to route Keycloak connections to the different data center, which it should be if based upon how you set up your secrets. So in this case, I'm starting it at 0, and we'll see us bring it up. Now, I'm hand-waving one thing on the multi-Kubernetes cluster aspect, which is that to save some kubectl context switching, I actually deployed this cluster to a namespace that I called data center 2, or DC2 here. So you can imagine that these are two different data centers. This example works if you're going to two different Kubernetes clusters. Just for simplicity for the demo, so we're not constantly kubectl context switching, I'm just doing it in multiple namespaces. So, I'm an open source person, so I try to give full transparency on all of the examples we go through. So let's see how we're doing in terms of bringing up our Postgres cluster. Let's see if we're up yet, and I'm going to do it the risky way, which is let's just run a query against the database. Cool. So notice we're on the DC2 database now, and it is up and running. Let's take a quick look at the pods that are there. So yeah, we can see our database pods, and we can see one of our backup repository pods is already there. How do we know this is actually a standby cluster? Well, I'm going to tell you that this command in Postgres, PG is in recovery, If it returns true, that means that it is it's in replay mode, or basically it's it's basically accepting changes from a different database. In this case, it returned true, so this is definitely a standby cluster. And I'm going to run this command just to synchronize the value of the key cloak secret between our primary cluster and our standby cluster. There's different ways you can do this. You could use, for instance, an operator that synchronizes secrets between two different data centers. I'm just doing this, the hand wavy way, just for the sake of simplicity of the demo. Last but not least, let's see the status for our backups in our standby data center. We can see that we are using the backup, and if we did a reference against it, we're leveraging the backup from the from the primary data center that's in S3. So cool. We have our standby cluster set up, and it's ready, willing, and able to be promoted. So let's go into like a full day 2 operation and promote that. So the first thing to do is, this is a classic database technique, is to shut down. We want to make sure that our primary data center is no longer active. We want to try to avoid split brain. And in this case, we can control it. We can explicitly say shut down data center 1, or shut down our Postgres cluster there. So we shall go ahead and do that. Of course, that's why I should copy and paste my command so I don't have to think about it. So let's watch what happens. So this is interesting. So first, what we're going to do is we're going to shut down all the replicas. Again, we do a safe shutdown to make sure any active transactions get flushed to the disk, or get pushed up to the backup repository. We then terminate the primary, and then we'll be after that we'll be safe to promote the backup data center. Yeah, I just want to show that everything is no longer running there. So, but we have a key cloak running. I didn't shut that off, but that is on me to improve the demo in that regard. All right, so let's promote our standby cluster. And promoting a standby cluster is as easy as shifting enable to false. And this time, what am I doing? Oh, let's see. So the other thing, sorry, I forgot one thing. This is why I script things out. We're also going to bring key cloak up as well, since now we're promoting the standby. And that being said, let's do that. So the fun thing here is that when we promote the standby, it's almost instantaneous. The database is already up and running. But key cloak is going to take a little bit to boot up. Some of that is just based upon the key cloak application itself. Just for clarity on the demo, I'm going to set a new port forward to key cloak, and I'm going to do it on a different port. I was running on 5000 before. I'm going to go to 5001, and that's just to be clear that we're accessing key cloak from that different data center. So let's see if key cloak is up, running, and ready. Not just yet. Okay. I just want to show everything is working. There we go. All right. So here we go. We're back in key cloak. It's a new session because we did restart our pod, so it's a new session, but it's also a different key cloak instance. And there we go. We still have our data. It's the data that we have from the primary data center, but this is key cloak connected to our standby data center cluster, which is pretty cool. I think it's pretty cool. So make sure. First off, let me change the data, show that it's actually writable. That's a success. All right, we can see that the data did exist in the DC2 database. I will confirm that that database is actually writable. So PG's in recovery returned false. And what I'm actually going to do is I'm going to make sure that we get a backup saved to our, we have 2 backup repositories in this case, one in S3, one in the local storage. So I'm triggering a backup in the local storage to make sure it's there, because that's going to come into play in our next scenario. One moment, please. All right, so let's make sure that backup is complete. All right, so we have a backup to that data center. Now, we're going to attempt something that is a bit Sometimes I get it correct in the live demo, sometimes I don't. And this is going to be called a point-in-time recovery. Now, a point-in-time recovery is an operation you need to be very careful of. Basically, it allows you to roll back your database to a specific point in time. What do I mean by that? The classic example I like to use is dropping the users table. If you're ever doing work in your production database, always do it in a transaction. Always type begin first, and then go ahead and make your changes. Because if you don't do that, you might accidentally drop your user table. Now, I will say personally, I don't think actually, did I ever drop the user table? I probably did drop the user table at least once, but thanks to point-in-time recovery, I'm able to recover. Pigo offers two ways of doing a point-in-time recovery. The first, and this is the preferred method, and the method I strongly suggest you use if you ever have to do it, is you create a new Postgres cluster and you do the point-in-time recovery there. This allows you to at least futz with what's going on to make sure that the data is in the state in which you would like for it to be in. The second method is you could do it in place. And that's a little bit riskier because if you mess up the point-in-time recovery, you may not be able to go back to the point in time that you wanted to. So I'm just gonna do a little bit more munging of the data just to make sure I really screwed it up. And we're gonna try to go back to the previous state. So what we're gonna do is first I am going to go in and I am going to modify our manifest to set the point in time recovery. So we're gonna be using the backup from the local backup repository within this new Kubernetes cluster that we set up because it'll be a little bit faster to perform than me going out to S3. So let me see if I can set the time correctly. The time will be in UTC because that is what our container time is set to. Let's see how good my math is. So from here it's +5. So let's do 1735. So the reason like I'm trying to be careful about it is usually I get this correct in the live demo, but based upon how Postgres looks for some of the archive files, when you're doing the restore, usually in your truly active database, this is no issue. But because we're slightly idle, even though we have a production application hooked up to it, there might be no write-ahead logs present in the backup. So I just want to make sure that we have that actually done. So I guess now without further stalling, and hopefully I'm being overly paranoid and this actually will work fine, let's prepare our in-place point-in-time recovery. So because an in-place point-in-time recovery is a destructive operation, you have to do it in 2 steps. I still say that it's a declarative way of doing it, but there's a second step. So we declare this is what we want a point-in-time recovery to look like, and we say it's enabled. But to truly carry it out, you have to set an annotation. It's a 2-key method. Is to make sure hey, you're really sure of doing this. So even though you have to run the the annotate command, we still apply the annotation to the manifest, and then the point-in-time recovery begins. So let's see it occurring. So you can see that our restore job is running. That was pretty fast. And should I set everything up correctly, we will see our Postgres instances come back up, and they will be up and running and healthy. Let's see, did I do it? There we go. Oh, I think I did do it. So I did bring Keycloak down. In part, Keycloak actually has some caching layers I discovered while doing this live and seeing things not work. So we're going to scale Keycloak back up, which means I'm going to have to restart our port forward. It'll take Keycloak a minute to come up. But we should hopefully see that our munge data gets unmunged when we do the refresh. Hopefully I picked the correct time. Now, the reason why I'm spending a lot of time on point-in-time recovery is that I find this happens more often than not when you're running databases in Kubernetes. And I'll back up a second and say, a lot of people focus on high availability. And in fact, I did. It's great to have your data up and running and available. But the storage layer in Kubernetes, I say, is something that's fundamentally, it's both still being developed. It's certainly improved, even since I started looking at it. But in a distributed system, particularly when you're using network storage, a lot can go wrong. And suddenly you might find out that something that you thought was written to disk may not be, and you need to restore, or something got corrupted or whatnot. So while people emphasize high availability, I always emphasize backups. make sure you back up your data. Don't have one backup, have two backups. Actually, with Pico, we let you store backups in 4 different places, and we may even expand that, for the people who want to be really careful about that. But take backups. Like, we try to make it as easy as possible to take backups, and likewise, we try to make it as easy as possible to to recover. Organizations have RTO and RPO requirements. We want to make sure that you're able to meet those. So it looks like we have KeyCloak up and running. Let's refresh. And let's see, did we restore our data? We did it. Yes, it always feels good when you do a live point-in-time recovery successfully. I mean, I can tell you when having done like real point-in-time recoveries, like you sweat bullets when you're doing it. And I remember a scenario where I had to do a point-in-time recovery, and it probably took me 2 days to set it up to my liking. It was a scenario where some data wasn't saving, appropriately, within the database, but we did have all the historical data, so we were able to snapshot and get the information we wanted, but I had to manually set up this point-in-time recovery. Something like, with Pico, I don't need to worry about that. I just need to like put in my various times and move forward in the timeline, and the operator orchestrates all of that. And that's like some of the some of the understated power of using an operator to manage your databases is that you can encapsulate like some of these normally very complex operations and simplify it and make it more accessible. Like I said, like I'm an accidental DBA. I'm truly an application developer, but having something that gives me access to more of the DBA operations in a way that's simpler to handle makes it much easier to run production Postgres on my own. So let's as I mentioned, it's possible to schedule backups. We're not going to get into that. And looking at the clock, I want to make sure we save time for questions. So let me do one more quick thing with our cluster, and that's to set up a connection proxy. Often you set up a connection proxy for dealing with more throughput of your applications. You have a lot of connections, and you want to put an appropriate load on them. Basically you want to scale your connection load appropriately in your Postgres database. So we use an open source connection pooler called PG Bouncer. You can see that's already up and running. And what's cool, and I forgot to show you what the user secret looks like in the beginning, is that as soon as you add the PG Bouncer, the user secret gets updated to have the connection credentials to it. So again, you don't need to pass the credentials around. You could just plug them right into your manifest. So let's do that. Here's KeyCloak. Just say PG Bouncer host, PG Bouncer port. Again, I can be blissfully ignorant of what these values actually are. Boom. So it's reconfigured, and we do need to wait for the changes to roll out to the KeyCloak pod. So we'll give that a moment. But yeah, just going back to here, the idea with like the user having the credentials and the secrets is that you can disallow direct access to your secrets. People, your users can just connect their applications to the database and set and forget. And if you need to rotate the credentials, you can do that. You don't need to pass them around. It is truly a wonderful set and forget experience. My favorite was as the accidental DBA. Excuse me. Okay, so it looks like we have KeyCloak up and running again.
Oh, one thing, Jonathan, real quick question. Got a question from the audience. This is the Postgres Operator version 5, right?
Correct.
Okay, cool. Got it. Thank you.
Sure. Welcome. All righty. So what did I just do? So I guess I restarted KeyCloak. Let's make sure everything's still up and running. So we log back in. I can continue to munge our data. And well, how do we know that we actually went through a connection, the connection pooler? I can make it somewhat easier to look at. Well, first, let me prove that the data still exists. And it does. There we go. There's our wonderful munge data. And if we look through the stat activity, I'll show you our, there's a special administrative PG Bouncer user, which of course, whenever I do it in this view, you can't see it. Oh, here it is. But we also have, KeyCloak connecting, through the JDBC driver through the PG Bouncer user. So, this allows us basically to, easily tie our application into back to our database, through the proxy. So last but not least, monitoring. Let's look at monitoring. And one thing, monitoring is, I think it's something that needs to be, it goes hand in hand with running things in production. You need to have visibility into what you're doing. And I think the Kubernetes community does a wonderful job of making monitoring accessible, making visualization accessible. So we basically with Pigo leverage some of the wonderful open source monitoring tools available, Prometheus, Grafana, Alert Manager, to provide us some turnkey Postgres metrics. So let's look at some of those. So you can see our two clusters. Well, one is our primary data center is definitely down, but we have a HA cluster in the second data center. We can go in and look at the details of it. And it's essentially the stats that one would expect. Let me go over the last 5 minutes. There we go. So and when I say the stats that you expect, I think the stats that Postgres DBA expects. What's your connection saturation? What's the size of your database? What's the workload on the database? Is there any replication lag? How big is your write-ahead log directory growing? Things that you typically look for in troubleshooting. You get details about the pod. You get details about the backups. When was your last backup taken? What's the size of your wall archive? What's the size of your backups? Are your archives appropriately pushing? And even things like query statistics. What are my slowest queries? Let me just look inside Keycloak. So I guess we're not running too many queries inside Keycloak, so it's not all too interesting. But let's do all again. How many queries are running? Which queries are taking up the most time in aggregate? Which queries are just taking up the most time individually, and so on and so forth. So all the metrics that you would expect to debug your database. So I am pleased to report that this concludes the demo. I have a couple more slides that recap it, as well as destroying the cluster in the end. But I figured this would be a good place to pause if there are any questions, in case there's additional things that we can demo today.
Obviously, this, we've done 111 live streams. This is our 112th. Very, very well explained. I guess, thinking from the perspective of folks that are out there that are approaching this challenge of, okay, let's run database on Kubernetes. For you, what are the things that have been difficult for you in this process, or what are the things you might anticipate that could be perhaps easy mistakes to make?
Yeah, that's a great question. So I would say, when I first came to Kubernetes, I think, and this was back in I think Kubernetes was just at 1.11, maybe it might have even been 1.10. First, if you're just diving into Kubernetes, the community moves fast. It's hard to keep track of everything. I'm lucky I have some good friends who are way smarter than me that feed me the high level points on it. But you can still go back to the basics. I would say even before you start running a database in Kubernetes, I'm going to plug a book that I get zero commission on, but this finally helped put Kubernetes in perspective. It's called Kubernetes in Action. And even though it was originally written, I think, around Kubernetes 1.4, and the author's working on the second edition now, it just covers all the fundamentals are still the same. And that's what Kubernetes got correct in the beginning, fundamental architecture. You understand the workflow, you understand how it works, that gives you a leg up in things. So let's go into databases. The premise of this talk, and even the premise of my work on Pigo was, it's actually not that hard to get a database up and running in Kubernetes. I'm not gonna lie to you. You can get database up and running. You're gonna have a lot of challenges running it in production if you don't apply automation to it. And I would strongly say, whether you use Pigo or any other operator, that you want to have an operator against your databases. Why? Chaos. Things are going to break in Kubernetes, no matter, especially as you add more and more nodes, things will break. And it's no fault of Kubernetes. I think, given the massive scale of Kubernetes, I think it's amazing, how well things work in general. But beyond anticipating that there will be chaos, I think the biggest mistake people make is they focus so much on availability. They're I want high availability, I want rapid failovers. And look, I can give you all of that today. Focus on where your data is being stored. Focus on the storage layer, which storage system you're using, and most importantly, focus on the backups. Pigo is actually very opinionated on backups. We force you to have at least one backup repository, and not everyone likes that. They're oh, I want to run this in development. I'm okay, that's fine. And perhaps in the fullness of time, we will let you disable backups. But by default, we force backups because that cluster you're running in development may one day be your production cluster. And if you don't have your backup set up, you're going to be in trouble. And I've seen, the biggest mistake I've seen is, people not caring for their backups and then running into an issue where there is corruption on their primary database. And the corruption gets replicated to the different instances. And keep in mind, having a replica is not a backup. It may, in certain scenarios, it may help you restore more quickly, but backups are backups. They're their own thing. Focus on the backups. Ensure you understand your backup strategy with your data in Kubernetes. This extends beyond Postgres because there's a very strong probability you will need to use them. And then test your backups. Make sure you can restore. I would say probably most of the issues reported in GitHub do come around backups, and for a variety of reasons. But typically it's things at the storage layer that we're troubleshooting, and we just want to make sure that you're able to store your data safely in Kubernetes. Like, I feel totally comfortable running my applications in production on Kubernetes with Pico. I'm willing to stand behind that. And the reason is just focusing on those layers. Everything else will but it sounds funny, but I'm like, high availability actually I think comes fairly easy. Like, Kubernetes gives some wonderful constructs to give robust HA solutions. So I emphasize to people focus on the backups. Last but not least, monitor. Get those insights. You want to be able to anticipate problems before they become problems. And it sounds, and sure, that's marketing, buzz speak, but it's true. It's much easier to avoid a problem, like running out of disk before, before it happens. Does that answer your question?
It does, and very, very well. What I would like to take a little bit further, and this is something we've kind of asked several different speakers, and we've seen a wonderful, both slide presentation as well as the demo regarding how this is done. Taking it a step, taking a step back or even a step forward, the how is one thing, the why being another one. And I say this because this is something that we get as feedback from folks that might not be 100% convinced that this is something that their organizations are ready for or things of that nature. But if someone asks you, why should I do this? How would you respond to that?
Yeah, so I think that's a very good question. It's something I ask myself every day because I think the why does drive the product innovation. In some cases, the why is simple. It's that we have an organizational mandate. We're moving to Kubernetes or some variation of Kubernetes, and that means everything, including our databases. So how can we make sure we can run our database workloads, as close as possible to the application? But I think that's a cop-out answer. So I'm going to give a more abstract one. It's when you're comparing against managed services or running on bare metal or just not using an operator. Why would I do this? So there's a few reasons. One, it's having control over where your data is deployed. And I can make an argument that even with a managed service, you have some control over that in terms of zone. You might not have control in terms of provider unless I give a quick plug for Crunchy Bridge, where Crunchy Bridge does let you choose which cloud you want to have things hosted in. But something Kubernetes is much more is powerful in the sense that with that API, my node can live anywhere. It can live in any cloud. It can be public, private, hybrid, anywhere. That means I can deploy my data anywhere. And it's the same API, the same way to manage it, no matter where it is. So if I want to have a uniform way of managing my data, and I want control over where I'm deploying that and not need to worry about the underlying infrastructure, that is why I would deploy my data on Kubernetes. That is a very powerful concept. Now, look, it's not without its challenges because, in addition to, managing your Kubernetes infrastructure, you're then managing your data. And some people may have been, managing their databases for years and, they're very comfortable with dealing with all the challenges that come with that. They're the people on the Crunchy staff, before they joined Crunchy, they were managing, I forget, 10 or 20K Oracle databases. They've since made the switch to Postgres, but, with that kind of institutional knowledge, I think you get a leg up in terms of managing everything in Kubernetes. Now, we can certainly go into a lot more specifics. Why run a database in a container? You're able to lock down the entire file system instead of except for your database directory. It's easier to shift your workloads around to the various different nodes. There's certainly all this the semantics, but it's really looking, it's really solving the higher level question of why, which is, why even go through this rigmarole? And, the answer I always come back to is, the freedom to move my data around. And look, it's rare that you do move your database, but that does happen. Like when, in my accidental, senior DBA role, or what have you called it, I would move my data. Like if I got a very competitive price from a data center, yeah, I would move it, and then I'd have to like ship everything around. So hopefully this at least starts answering the why. I think we literally could spend an hour just discussing this.
Easily. No, but it's refreshing to hear that perspective. One question that we got in the chat: can you do a major upgrade of Postgres with this operator, or can we use other scenarios like logical replication or PG dump?
I have a slide on that coming up.
Oh, no spoilers. All right, we'll take it away with your slide then.
Cool. So let's bring it on home and do the rest of the questions. Because actually, I do want to do a quick demo recap, if that's okay.
Yeah, go for it. Yes.
Yeah, because we saw a lot today. Like I tried to show like as much as I could of the entire like database lifecycle, things that happened in day 0, day 1, day 2. From how we deployed a production cluster, like fairly simply. As close to like a one-click install as you get to Kubernetes. I mean, just a manifest and kubectl. You were able to handle maintenance operations with, in this case, no downtime. We did as straightforward as possible of a multi-cluster demonstration. Again, I cheated a little bit by just using like 2 namespaces, but this applies to running databases in different clusters. We successfully did point-in-time recovery in place, which is always the part like I sweat bullets on. And we looked at the monitoring, and we looked at being able to create a connection pooler as our application starts getting more throughput to it. So spoiler alert, there's a new version coming out at some point this quarter. It's going to have Postgres major version upgrades, and it's going to be a fully declarative way of doing it. We also added in the pgadmin 4 user interface for managing databases, and some enhancements to rolling updates as well. Particularly operations where we don't need to destroy the entire pod. We can such as changing a Postgres variable that requires a restart. You do the rolling update just like that. To answer the question about doing a major upgrade using logical replication. You can do that. We don't provide the orchestration for it. That's certainly possible. That sounds like a wonderful blog post for someone to write. But the operator will orchestrate, managing the 2 clusters, but you would have to orchestrate the logical replication. I do have a blog post out there on creating like an active, multiple Postgres writable nodes all speaking to each other using the Postgres operator. So let me just bring it on home, and then happy to answer any more questions. You can find out more. There's the product pitch page if you're interested in, as well as the open source code. The Pigo is entirely open source, so feel free to inspect it, deploy it, beat it up, submit patches, and so on and so forth. And the examples as well, which you really should use the examples with the tutorial that comes in the documentation. So with that, I am done and ready for any other questions that you have.
No, I think very, very, very complete. Obviously, you're pretty easy to find if folks want to continue the conversation. But just want to give everybody a chance, that's in the chat right now. If you have any additional questions, feel free to get them out there. If not, we can definitely continue the conversation in Slack. This was very, very good. This is very, very good. And I really do, like I said, we've asked lots of different folks their opinion about, why run data on Kubernetes, and also addressing the issues and mistakes. Like you said, it's not that there's, one size fits all for everybody on this. You mentioned, having one book as a reference. Other folks can have other resources that might work for them. The point is that there are lots of different ways to reach the same objective. I think part of it is, make open source and community a part of your strategy about how you learn this, so you don't have to do it 100% alone.
Yeah.
And like you said as well, too, because the ecosystem is evolving so quickly, for some folks, it can be a little bit overwhelming sometimes. But, as fast as things are going, you can also slow them down. That's why we have live streams like this one, to make these things simpler. Maybe, can I just get you to stop sharing your screen really quickly?
Sure.
So I can share mine.
Yeah, go for it.
We have a little bit of a tradition in our community. So while you were talking, we have a very talented artist who's creating an artistic rendition interpretation of the things that were covered in the live stream. Wow. Obviously not all of them, because you got through a lot in an hour. I mean, there was not a dull moment. There wasn't a single lapse at any point in time in terms of content from both a slide presentation as well as a demo. But I think it's just nice to see a visual representation, an artistic rendition of the things that were covered.
That person is way better looking than me. So many kudos to the artist. But I'm gonna thank you.
No. I think it's quite accurate. So anyway, I guess since we're getting towards the end, is there anything that you didn't recommend Kubernetes in action? Any other resources and things like that? You put some great links there too. And we'll be sharing the slides, just so everybody knows. We'll be sharing the slides as well, so people can check that out. Any other resources that you recommend, or things that you think folks should anticipate in the near future?
Yeah, that's a good question. So I mean, I think the way I learned Kubernetes was actually similar to how I learned Postgres, which was first I just did it. Like I tried, I don't know how to say it, like I used my street knowledge of running technology. But certainly like tying it into something real always helps. I think actually what helped crystallize a lot of the version 5 design of Pico was taking real applications like Keycloak, putting it through things like Argo and seeing, how are people actually trying to deploy their applications. It's actually really cool. I'll plug, I want to get the name of the project correct. I believe it's the service broker operator, which basically helps bind credentials between, different, stateful services. Seeing them use Pico as an example for how to do that was really cool. But again, also makes you, for me, that also really makes me think, like, how are people actually connecting to their databases? Because that's really the initial start. The Kubernetes documentation is great. I think that's where we constantly reference it, even in the Pico code base for how to do particular things. But I think that was the other way I learned Kubernetes, was I just went through the Kubernetes tutorial and the documentation. And by the way, just as someone who's contributed to the Postgres documentation lightly, I am just like blown away by like all the contributions to the Kube documentation. Like it's really a cool ecosystem, and it's solved a lot of the problems of how do you do these things. How do you contribute at scale.
Agreed. And as someone who's involved in the CNCF as well too, yeah, the sheer number of contributors and stuff that's going on is very, very impressive. And it's a very warm and welcoming community if folks haven't checked that out. Postgres is also a very, very vibrant community. We have different members in the Data on Kubernetes community that are very active there as well. So always nice to have a live stream about Postgres. Jonathan, thank you very much. I can't wait to have you back. So we got to find an excuse to get you back on. Hopefully as well too, as a reminder, folks, you can get your CFPs in for our co-located event in KubeCon. We'll definitely be having something about Postgres. Not sure exactly what it will be, but Jonathan, I highly encourage you to submit a proposal as well. And anyway, thank you very much for your time today, and looking forward to connecting again.
Yeah, great. Thank you, Bart. Thank you so much. It was great to finally do this. This was a lot of fun.
We did it. It was totally worth it. It was worth the wait, and can't wait to do it again. So thanks a lot, everybody. We'll see you next week.
Awesome.
Take care.
Awesome.